Hey everyone, and welcome to our deep dive. Today we're going to be talking all about prehistoric creatures.
Yeah, it's always fascinating to kind of look back at, millions of years and see how, these creatures lived and thrived.
Exactly. And what made them so successful? We always hear about dinosaurs, but what were their adaptations?
Right. And how did those adaptations allow them to survive, in such different environments than we see today?
Yeah, so let's start off with a creature that I find very fascinating, Spinosaurus.
Oh, yeah.
The one with the big sail on its back?
Yes.
For years we always thought that this is like the aquatic, predator.
Ultimate aquatic predator.
But new research suggests that it might not have been the swimmer that we thought.
Yeah, and that's been a big debate in paleontology for a long time. That classic image of Spinosaurus, deep diving, chasing fish.
Right.
But, recently scientists have been looking more closely at the skeletal structure using CT scans.
So like 3D X-rays.
Yeah, exactly. And it's revealed some interesting features that make us rethink that whole deep diving idea.
So what did the CT scans show?
Well, one thing they noticed was that the center of gravity in Spinosaurus seems to be positioned more forward in the body.
Oh, okay.
Which, if you think about it, makes a lot more sense for an animal that's walking on land.
Right.
If you're trying to swim and you've got all your weight at the front, it's not going to be very efficient or graceful in the water.
So not an Olympic swimmer.
Right, not winning any underwater races.
Oh, yeah.
Yeah.
What else did we learn about Spinosaurus?
Another interesting finding is its bone density.
Okay.
It seems like Spinosaurus was a lot more buoyant than we initially thought.
Yeah.
Kind of like a hippopotamus,
Oh.
which, spends a lot of time in the water, but is also very comfortable on land.
Right.
And this buoyancy combined with its long snout, that crocodile-like snout,
Mm.
and the conical teeth, those are teeth that are perfect for gripping slippery prey. It suggests that maybe it was more adapted to hunting in shallower waters,
Okay.
or maybe ambushing prey at the water's edge.
So instead of being like a shark, it was more like a heron, waiting in the water.
Exactly, yeah, a much more patient hunter,
Yeah.
waiting for the perfect opportunity to strike.
Yeah, that's super cool. I love that idea of Spinosaurus waiting,
Yeah, it's really changed our perception of this animal.
Yeah.
It's still a fearsome predator, but it's got a different kind of strategy.
Yeah. Yeah. More thought out.
A little more nuance to it.
Yeah.
And, it's perfectly adapted to that environment.
Speaking of adaptations, let's talk about a dinosaur that was really good at surviving in a world where water was pretty scarce. And get this, it looked like a goose.
A goose dinosaur. Yes, that's right. It's called Multidentames. And it's part of a fascinating family of dinosaurs called Hulscaraptorinae.
Wow.
And it's really incredible to see how evolution can produce such a diverse range of forms.
Yeah, a goose dinosaur.
It's not what you typically think of.
It's not what you think of when you think of dinosaurs.
No, but it's this small dinosaur about 1/2 meter long.
Okay.
And it's got this long neck and a flattened snout. Just like a goose.
Okay. I can kind of picture that now.
Yeah.
But why would a dinosaur evolve to look like a goose?
Well, all the members of this dinosaur family that we know of so far were found in Mongolia.
Okay.
And during the time they lived, there was extreme drought.
Wow.
Water was really scarce.
So it was like survival of the fittest, basically.
Exactly. They had to adapt to find those limited water sources.
Yeah.
And, their body shape suggests that they were streamlined for swimming.
Okay.
And they even had these specialized sensory organs in their snouts, kind of like crocodiles have, so they could detect prey underwater.
So these goose dinosaurs were really good at navigating these tough conditions.
Exactly.
Yeah.
And they could find food and survive in a landscape where a lot of other animals were struggling.
That's really interesting. So it just goes to show that, evolution can drive some crazy adaptations.
Yeah, and who knows what else is out there in the fossil record waiting to be discovered.
It really makes you wonder.
Yeah, it's just the tip of the iceberg.
Absolutely. And sometimes, those discoveries come not from bones, but from something a little more delicate, ancient DNA.
Yeah, that's right. Ancient DNA can tell us so much about the past.
So are we talking like Jurassic Park here?
Not quite.
Okay.
We're not cloning dinosaurs yet.
Okay, good to know.
But scientists have been able to extract ancient DNA from sources like permafrost.
Permafrost, so like the frozen soil.
Yeah, exactly.
DNA can survive in that.
It's amazing, right? Permafrost acts like this giant freezer.
Wow.
And it preserves the genetic material of organisms that lived millions of years ago.
It's like a time capsule?
Exactly. And recently, scientists extracted 2 million-year-old environmental DNA from permafrost in Greenland.
2 million years.
That's the oldest DNA ever sequenced.
Wow, what did they find?
Well, they found DNA fragments from a whole range of plants and animals.
Like what?
Things like mastodons, reindeer hairs,
Wow.
even birch trees. It paints a picture of a very different Greenland than we see today.
So 2 million years ago, Greenland was like a lush forest.
Yeah, it wasn't the icy landscape we see now.
Wow, that's crazy.
It's really changing our understanding of how ecosystems evolve over time and how they respond to climate change.
That's so interesting. I love that.
It's giving us a glimpse into a lost world.
Yeah, and it shows how resilient life can be,
Exactly.
surviving even in those extreme conditions.
And speaking of resilience, let's talk about a creature that might just turn our understanding of bird evolution upside down. Have you ever heard of Janusaurus?
Janusaurus, that name sounds familiar, but I can't quite place it.
Well, it's this primitive bird.
Okay.
Lived about 66.7 million years ago.
Wow.
And its discovery has been quite a shakeup for paleontologists. You see, for over a century, scientists have categorized bird skulls into two main groups. You've got the paleognaths. Those are birds like ostriches and emus.
Okay.
And they have fused upper jaw bones.
Okay.
And then you've got the neognaths, which include most other birds.
Okay.
And they have mobile upper jaw bones.
So fused and mobile.
Exactly, two basic types. But here's the thing. Janusaurus, despite being a primitive bird, had a mobile upper jaw.
So this little bird is like rewriting the evolutionary history books.
Exactly. It's challenging our long-held assumptions about bird evolution.
Wow, that's so cool. So it basically means that the fused upper jaw on those paleognaths might actually be a later adaptation.
Yeah, it's like the evolutionary tree branched in a way we didn't expect.
It's like the family tree got a little messy.
Yeah, a little bit.
All right, well, let's move on to a creature with a tail that might have been more for show than for defense. Tell me about Ankylosaurus.
Ankylosaurus, the walking tank of the dinosaur world.
Why?
Covered in bony plates and wielding that powerful tail club.
Yeah, that's what we always think of.
Right, it's always been portrayed as the ultimate defensive weapon. But recent research has started to question that assumption.
Really? So you're telling me that those powerful tail clubs weren't just for smashing into predators?
That's what the evidence seems to suggest. Scientists have been studying Ankylosaurus fossils, and they've found a surprising pattern of injuries.
No.
And these injuries are specifically around the hips.
No.
And they seem to be consistent with blows from other Ankylosaurus tails.
Oh, so they were fighting each other.
That's a very real possibility. It
Yeah.
seems like they might have been using their tails for social dominance.
Like jousting almost.
Exactly, like some kind of prehistoric jousting tournament.
So instead of using their tails for defense against predators, they were actually battling it out among themselves.
Yeah, maybe for mates or territory.
Wow, that's a completely different picture of Ankylosaurus than I had before.
Right, it's not just a passive defender, it's an active participant in its social environment.
That's really cool. I love that idea.
Yeah, it really adds another dimension to our understanding of these creatures.
Yeah, it's like they had complex social lives. That's so fascinating. I can't wait to hear about more creatures.
Well, we've got plenty more to talk about, so stay tuned.
All right, everyone. We'll be back after a short break to continue our deep dive into the world of prehistoric creatures.
You know, it's amazing to think that a single bone, a little fragment of DNA, can tell us so much about these animals that lived millions of years ago.
I know it's mind-blowing to think that we can reconstruct their lives, their behaviors, just from these little pieces of evidence.
Yeah, it's like we're piecing together a giant jigsaw puzzle of life's history.
And sometimes those puzzle pieces fit together in ways that we totally didn't expect.
Exactly like with the Ankylosaurus.
You know, right? Who would have thought that those tail clubs were more for show than for actual defense?
It's a good reminder that we should always be questioning our assumptions and be open to new interpretations.
Absolutely. Well, speaking of challenging assumptions, let's dive into a discovery that's really shaken things up in the world of paleontology. It involves a creature so bizarre, so unlike anything we see today, that it's forced scientists to completely rethink our understanding of early life on Earth.
Oh, wow, you've got my attention now. What kind of creature are we talking about?
We're going way back in time to the Ediacaran period.
Ediacaran period, okay.
This is about 635 to 541 million years ago.
Wow, so we're talking really ancient history.
Exactly. This is when the first complex multicellular organisms started appearing in the oceans.
So the very first complex life forms on Earth?
Pretty much. And these life forms are known as the Ediacaran biota.
Ediacaran biota, what were they like?
Picture creatures unlike anything you've ever seen before. Some were flat and frond-like, kind of like giant underwater ferns.
Okay.
Others looked like segmented discs or tubes.
Wow.
And some even had these strange quilted patterns on their bodies.
Sounds like something out of science fiction.
I know, right? They were truly bizarre and totally unlike any animals we see today.
So what happened to these strange and wonderful creatures?
Well, they actually thrived for millions of years.
Okay.
But then around 541 million years ago, there was a major extinction event.
An extinction event? Wow, what caused that?
Well, scientists are still trying to figure out the exact causes, but it was probably a combination of factors,
Okay.
like changes in ocean chemistry, volcanic activity, and maybe even the rise of new predators.
So a perfect storm of events.
Yeah, basically. And this extinction event wiped out most of the Ediacaran biota.
Wow. It's sad to think about all those amazing creatures disappearing.
I know, but it's also important to remember that extinction is a natural part of life's history.
That's true.
And it's thanks to these extinction events that new and more diverse life forms were able to evolve.
That makes sense. So the Ediacaran biota may be gone, but they paved the way for the evolution of all the amazing animals that came after.
Exactly. They were the pioneers of complex life on Earth.
Well, that was a fascinating trip back in time.
I know, right?
Yeah.
It's incredible to think about all the strange and wonderful creatures that have inhabited our planet.
It really is. And speaking of strange and wonderful, let's go back to Spinosaurus for a moment.
Okay.
Remember that giant sail on its back?
Oh, yes, that iconic sail. What was its purpose?
Well, that's a question that has puzzled paleontologists for decades.
I bet there are a lot of theories out there.
There are some scientists think it was used for thermoregulation.
Thermoregulation, so like controlling its body temperature?
Exactly. It might have helped Spinosaurus to absorb heat from the sun when it was cold,
Okay.
or to release heat when it was hot.
That makes sense. What other theories are there?
Well, others think it was primarily a display structure.
Okay, like for attracting mates
Hmm.
or intimidating rivals.
Exactly, kind of like a peacock's tail.
So Spinosaurus might have been showing off that sail to attract a mate.
It's a fascinating possibility, and it adds another layer of complexity to our understanding of this creature.
Right. It wasn't just a fearsome predator. It might have also had a sense of style.
A little bit of dinosaur fashion.
I love it. Well, speaking of style and social dynamics, let's move on to Ankylosaurus again. We've already talked about the possibility that its tail club was used for social dominance. But what else can we learn about its social life from the fossil record?
Well, some paleontologists believe that Ankylosaurus might have lived in herds.
Herds of Ankylosaurus, really?
Yeah, or at least they might have formed temporary groups,
Okay.
maybe during certain times of the year, like for breeding or migration.
So imagine a whole herd of these armored dinosaurs lumbering across the landscape.
It would have been an incredible sight.
I can only imagine.
And there's actually some evidence to support this theory.
Oh, really? What kind of evidence?
Well, paleontologists have found multiple Ankylosaurus skeletons in close proximity to each other,
Oh,
which suggests that they might have died together,
okay.
maybe as a result of a natural disaster or a predator attack.
So even though they were heavily armored, they still might have benefited from safety in numbers.
Exactly. Even the toughest creatures sometimes need to stick together.
That's true. Well, this has been a fascinating look at the social lives of dinosaurs.
It really has, and it shows that there's still so much we don't know about these amazing creatures.
Absolutely. Well, let's take a break, and when we come back, we'll continue our exploration of the prehistoric world. You know, it's really amazing how much we can learn about dinosaurs and other prehistoric creatures, even from just a few fossilized bones or, a tiny bit of ancient DNA.
It is. It's like a window into a lost world, and each new discovery just adds another piece to the puzzle.
Yeah, exactly. And it's fascinating to see how our understanding of these creatures continues to evolve as we uncover more evidence.
Absolutely. Well, speaking of evolution, let's revisit Spinosaurus for a moment. Remember how we talked about his adaptations for a semi-aquatic lifestyle?
Yeah, with that crocodile-like snout and those massive claws.
Right. Well, recent studies have been focusing on its tail.
Its tail.
Yeah, which was unlike anything we've seen in other theropod dinosaurs.
Really? So what was so special about its tail?
Well, it was long and deep, and it had a series of tall, bony spines extending along its length.
Like a sail on its tail.
Kind of, and scientists think that this tail might have acted like a giant rudder.
A rudder. So like helping it to steer in the water?
Exactly. It would have helped Spinosaurus to propel itself through the water and maneuver more efficiently.
So instead of just wading in the shallows, it might have been a more active swimmer.
Yeah, that's a fascinating possibility. It really changes our view of Spinosaurus as a predator.
It really does. It's incredible how new discoveries can completely shift our understanding of these ancient creatures.
It's true. Well, speaking of changing our understanding, let's move on to a discovery that has completely revolutionized our view of bird evolution.
Okay, I'm intrigued. What discovery is that?
The discovery of Archaeopteryx.
Archaeopteryx. Ah, yes, the iconic feathered dinosaur.
That's the one. It's long been considered the missing link between dinosaurs and birds.
Yeah, I remember learning about Archaeopteryx in school.
Well, recent studies using advanced imaging techniques have revealed some surprising details about its anatomy.
Oh, really? Like what?
Particularly its wings and feathers. It turns out that Archaeopteryx had a more complex wing structure than we previously thought, with features that are more similar to those of modern birds.
So it was more bird-like than we realized.
Exactly. And the studies also showed that his feathers were arranged in a way that would have created aerodynamic lift.
Meaning that it could actually fly.
That's right. Archaeopteryx was capable of true powered flight, not just gliding.
Wow, so it wasn't just a transitional form, it was a true flyer.
Exactly. And this discovery pushes back the origins of avian flight even further than we thought.
That's incredible. It's amazing to think about all the different stages that evolution went through to produce the birds we see today.
It's a reminder that evolution is a complex and gradual process, and there are always surprises waiting to be uncovered.
Absolutely. Well, speaking of surprises, let's move on to a creature that had to adapt to one of the most challenging environments on Earth, the vast open ocean. Have you ever heard of Plesiosaurus?
Plesiosaurus.
Yeah.
Yeah, those marine reptiles with the long necks and flippers.
That's right. They're a classic image of prehistoric marine life.
So what made them so special?
Well, for one thing, their necks were incredibly long, sometimes even longer than their bodies.
Wow, that's a long neck.
And they had a unique way of swimming, using their flippers to propel themselves through the water, like underwater wings.
Underwater wings. That's fascinating. How did that work?
Well, imagine a bird flapping its wings, but instead of moving through the air, it's moving through the water. Plesiosaurs likely used a similar up and down motion with their flippers to generate thrust and maneuver.
So they were like underwater birds.
You could say that, and their long necks allowed them to reach into crevices and under rocks to catch prey that other marine reptiles couldn't get to.
That's a pretty effective hunting strategy.
It was, and it allowed them to thrive in a very competitive environment.
It's amazing how evolution can produce such specialized adaptations.
It really is. Well, we've covered a lot of ground today, from land-dwelling dinosaurs to marine reptiles and even ancient birds.
It's been a fascinating journey through the prehistoric world.
And we've seen how these creatures adapted and evolved to survive in a wide range of environments.
It's a testament to the power of evolution and the incredible diversity of life that has existed on our planet.
It's truly humbling to think about the vastness of geologic time and all the amazing creatures that have come and gone.
It makes you realize that we're just a small part of a much larger story.
Well said. Well, that brings us to the end of our deep dive into the prehistoric world.
Thanks for joining us.
I hope you enjoyed our exploration of these fascinating creatures and learned something new along the way.
And be sure to join us next time as we continue to delve into the wonders of science and discovery.
Until then, keep exploring, keep questioning, and keep that sense of wonder alive.